One of my favorite fun facts that I've ever learned is that the term hysteria comes from the Greek word hystera, which means uterus. And hysteria was thought to be a madness unique to women, caused by their uterus wandering freely throughout their bodies. I'm not exaggerating when I say this is the foundation we've built upon in understanding women's bodies and brains. Granted, we've come a long way since then, but the menstrual cycle, pregnancy, menopause, these are all key biological events that affect women's bodies and their brains. And we know so little about what that looks like. When I learned another fact, that Alzheimer's disease affects women at twice the rate of men, it quickly grabbed my attention. Because we don't understand why women face this disproportionate risk. So what if we simply asked, how does Alzheimer's disease look different in men and women? And asking this question is a key part, but it's not quite that simple. The issue is our foundational understanding of the brain is built on data from men and male animals. The female animals were excluded because their hormones made them too variable. So when we think about why women face a greater risk for Alzheimer's disease, yes, we need to understand how the key characteristics of this disease look different in men and women so doctors know what to look for in adults at risk. But we also need to go back and consider how formative biological shifts unique to women are significantly impacting their brains, and we need to update our Neuroscience 101 content. In my research, alongside fantastic scientists in my lab, we asked how interactions between our immune systems and our brains might look different in older men and women. And what we find is that signaling molecules in our immune systems, the same ones that would help you fight the common cold, for example, are associated with aging-related changes in our brain structure. And this might increase risk for Alzheimer's disease. But the thing is, we only see this in women, and it's not present in men. And this is just one example of how we can't understand the biological puzzle pieces that determine how our brains function if we leave out women. And I'm so grateful to get to do this research in such a wonderful community at the CNLM, and especially to Mike and Manuela, who have supported me every step of the way since the moment I got here. Because when it comes to our brains, no woman should be left behind. Thank you.